Hello students, secondary to chemistry. Welcome you. This is the first period in the second term. The unit here is unit 3, bonds and forms of molecules. Now we are going to talk about the types of bonds. You know that this is a periodic table. Metals on the left hand side of the periodic table, non-metals on the right hand side of the periodic table. This column or this group is called inert gases or noble gases. These substances are metalloids. These are transition elements, main transition elements. These are the inner transition elements. The first group in periodic table contains one electron in the outermost atomic shell. The second group contains two groups in the outermost electron shell. Group 3A or 13. 3A or 13. This is 1A, 2A. This is 3A or 13. Each element here contains 3 electrons in the outermost orbital or orbit. Group 14 or group 4A contains 4 electrons in the outermost shells. Group 15 contains 5 electrons in the outermost shell. Group 16 or 6A contains 6 electrons in the outermost electron shell. Group 17 or 7A and contains 7 electrons in the outermost shell. This here are the noble gases. Contains 8 electrons in the outer shell, which is completely filled with electrons. Electrons of the outermost energy levels that play the main role in formation of bonds. This is called valency electrons. For example, here valence electron here is 1, valence electrons here is 2, valency electrons here is 3. These are the outer electrons that play the role in the formation of bonds. Chemical reaction. When a chemical reaction occurs, there is a change in the number of electrons of the outermost energy levels. This change is occurred by the bond formation or bond breaking between atoms, which aims at arriving to stability of the reacting molecules. Chemical reactions is also the breaking of bonds between atoms of the reactants molecule to form new bonds between atoms of the products. Here is a scientist called Lewis scientist. This scientist who proposed a simple method for expressing bonding by using dots to represent valency electrons. For example, this is oxygen react with carbon with another atom of oxygen to form carbon dioxide gas. This oxygen atom contains 6 electrons, 6 valence electrons. This carbon contains 4 electrons in the outermost electron shells. This is another oxygen atoms. The atoms combine together by sharing of electrons to form carbon dioxide gas, which is a stable gas. In the same way, 2 nitrogen atoms. The nitrogen is present in group 5A or group 15 with 5 electrons in the outermost energy level. This is another nitrogen atom to form N2, which is a nitrogen molecule. 2 atoms of nitrogen combine together by sharing of electrons. Each atom shares by 3 electrons. This atom shares by the 3 electrons to form nitrogen molecule. This method of expressing bonding is proposed by the scientist called Lewis, and so on. This is another example: phosphorus atom and 3 chlorine atoms. phosphorus atom contains 5 electrons in the outermost energy level, 5 electrons. Each chlorine atom contains 7 electrons in the outermost energy level. These are the electrons, the valence electrons, which is these electrons are represented by dots by the Lewis method. For the types of bonds, there are chemical bonds and physical bonds. Chemical bonds may be ionic, covalent, or metallic. Again, chemical bonds may be chemical bonds. Bonding may be chemical bonding or physical bonding. Chemical bonding, 3 types: ionic, covalent, metallic. There are other physical bonding. This is another type of bonds we are going to study later. For an ionic bond to be formed, the difference in electronegativity between the two bonding atoms must be greater than 1.6. 1.6 is the difference in electronegativity between the two atoms. If this difference is greater than 1.6 in electronegativity, the bonding between the two atoms will be ionic. Here is a covalent bonds. This type of bonds occurs when the difference in electronegativity between the bonded atoms is less than 1.6 and greater than 0. This happens by sharing of electrons. This is a covalent bond. Okay. The third type is called the metallic bond, or the sea of electrons, in which the electrons are delocalized between the bonded atoms. These are examples for ionic compounds. Sodium atom loses its outer valence electron, and this electron is gained by chlorine atoms. The electron is transferred to chlorine atoms to form sodium ion after losing these electrons, and chloride ion, which is obtained by gaining of electrons here. This is a positive ion and this is a negative ion, and the attraction between the two ions is called ionic bond. Here is a table for electronegativities of different elements in the periodic table: hydrogen 2.1, lithium 1, sodium 0.9, and so on. Each element has its own electronegativity. The electronegativity is the factor which determines the type of bonding. Here is a table for types of bonds: ionic bond, covalent bond, and coordination bond. These bonds, 3 types: ionic, covalent, and coordination, is called chemical bonds, while physical bonds are metallic bond and hydrogen bond. Metallic bond and hydrogen bond are physical bonds, while coordination bond, covalent bond, ionic bond are chemical bonds. Ionic bond have an attraction between the positive ion and the negative ion, as I said before, while a covalent bond can be classified into 3 types: polar covalent bond, non-polar covalent bond, and pure covalent bond. Here the ionic bond, we said that if the difference between the bonded atoms is greater than 1.7, if the difference is greater than 1.7, the bond will be ionic. Here in the covalent bond, the polar bond occurs when the difference between the bonded atoms is ranging from 1.7 to more than 0.4. If the bonded atoms have difference in electronegativity between these two numbers, the bond will be polar bonds, and we write partial negative and partial positive. Partial negative on the atom which has greater electronegativity, and partial positive on the atom which has low electronegativity. The covalent bond may be nonpolar. The nonpolar bond is formed between the two atoms if the difference in electronegativity between the bonded atoms is from 0.4 and greater than 0. For example, C and H. Here carbon has electronegativity 2.5 and hydrogen electronegativity 2.1. The difference between them is 0.4, which means that this bond is nonpolar bond. If the two bonded atoms are similar to each other, for example, fluorine molecule FFClClHH, two similar atoms, the difference here in electronegativity is 0, so this bond is called pure covalent bond. Also, some molecules are nonpolar compounds, such as carbon dioxide. Carbon dioxide gas, difference in electronegativity between carbon and oxygen is greater than 0, so it is nonpolar. But on the geometrical form of carbon dioxide is linear, so this compound is nonpolar. Here are three theories for explaining the covalent bond. The first theory, which explains covalent bond, is called octet-rule. Second theory is called valence bond theory, and the third theory is called molecular orbital theory. These will be studies later, inshallah. Now we say goodbye.